Hey guys, welcome to TechnoZard. This is Rohit Sharma, and in today's video I am going to explain you about the Norton theorem. And before this we have explained, we have done Thevenin theorem. Second one is superposition theorem. And if you have any doubt regarding these theorems, you can ask me in the Telegram group or in the YouTube comment section. And before starting the video, I would request you to please join the Telegram group, because daily many questions are solved there and many students are there who are preparing for ISRO technical assistant for various centers. Okay? Secondly, if you like the video, please share with your friends so that they can also be benefited, and please subscribe the channel so that I can also motivated to make more and more videos. Okay, let's start the video. Let's see what Norton's theorem states. Norton's theorem states that a linear two-terminal circuit. Two-terminal circuit is this something. Two-terminal circuit A and B. Okay. Two-terminal circuit can be replaced by an equivalent circuit. This circuit can be replaced by an equivalent circuit of a current source IN. IN is the Norton current in parallel with the resistor RN. RN is the Norton resistance, where what is RN? RN is the short circuit current through AB. ISC, or we can say IN Norton current. Or RN is the input or equivalent resistance at the terminals. RN is same as the RTH, which we calculate during Thevenin theorem, Thevenin resistance. Therefore, I can say Rn is equal to RTH, and if I have to convert Norton theorem into Thevenin, I can also say In is equal to VTH upon RTH. Okay, so I can say Norton theorem is the converse of Thevenin theorem. Okay, is the converse of Thevenin, or you can say Thevenin theorem is the converse of Norton theorem. Okay, next, suppose this is the linear two-terminal circuit. A and B is the output terminals. Here load is connected. I have disconnected the load and short circuited the load side, and this will be the short circuit current which we have to calculate. Okay, this is the linear two-terminal circuit, and we have converted in the Norton, and this is how Norton looks like. In this, a current source is connected in parallel with the Norton resistance. Or if I have to convert this into VTH and RTH, how can I calculate? We know that VTH V equal to IR, and therefore VTH is equal to Norton current ISC or IN into resistance RN. Therefore we can calculate VTH plus minus VTH. Okay, and we know that RN is equal to RTH, therefore this is RTH. This is how we can calculate Norton from Thevenin and Thevenin from Norton. Okay, and now we will do around 2 questions based on Norton theorem, so that each and every concept regarding this Norton theorem will be explained to you easily. Okay. Question number 1. Find the Norton equivalent circuit of the circuit in figure at terminal AB. What is Norton? Norton, in this one current source is connected in parallel with the Norton resistance. Okay. Now we have to find Norton current and the Norton resistance. Okay. Now first I am calculating Norton resistance. For Norton resistance, we have to turn off the independent sources. Current source will be replaced by open circuit, and voltage source will be replaced by short circuit. Okay, so we should see the circuit. 4 ohm, this is short circuit at 4, 8 ohm, 5 ohm, 5, 8, and this is 8 ohm, and this is A and B. Now we have to calculate Rn. Now you can see 8, 4 and 8 are in series. 8 plus 4 plus 8 will be 20, and 20 is connected parallel to 5. Therefore Rn is equal to 20 parallel 5. 20 into 5 upon 20 plus 5, which is equal to 20 into 5 is 100, 20 plus 5 is 25, 100 upon 25 is 4 ohm. Norton resistance is coming out to be 4 ohm. Now we have to calculate IN. For IN, we have to first redraw the circuit. Okay, current source 2 ampere. Okay, then 4 ohm resistance, voltage source plus minus 12 volt, 8 ohm, 5 ohm. And for calculating Norton current or short circuit current, we short circuit the load side there, ISC, which is equal to IN. See, 5 ohm, 8 ohm, 4 ohm, and this is also 8 ohm. and you are saying this shorts this in parallel with 5 ohm, we have short circuited the load, therefore the value here no current will flow. Okay, here zero current will flow. Okay, now if we redraw the circuit, what will the circuit look like? 2 ampere, 4 ohm, plus minus 12, 4, 8, and this is the short circuit current, and this is 8 and 8. Okay, and we have to find this current, that is IN or ISC. Okay, now if I am applying mesh loop, here I1 current is flowing and here I2 current is flowing. Okay, now we are writing KVL equation for loop 1. Loop 1, we don't write write anything. I1 is equal to 2 ampere, and loop 2, for loop 2, 4 I2 minus I1 plus 8 I2 plus 8 I2 and minus 12 volt is equal to 0. Okay, equal to 0. 4 I2 plus 8 I2 plus 8 I2, it is equal to 20 I2 minus 4 I1, which is equal to 12. Okay, 20 I2, I1 is equal to 2 ampere, this will be equal to 8 and this will be equal to 12. So 20 I2 is equal to 12 plus 8, 20. So I2 will be 1 ampere. I2 is equal to 1 ampere, and I2 is here equal to IN, Norton current or short circuit current, which is equal to 1 ampere. Now if we draw the Norton equivalent circuit, then 1 ampere current source is connected in parallel with the Norton resistance of 4 ohm. Okay, this is how we can convert a linear two terminal network into a Norton equivalent circuit. Okay, now come to second question. Using Norton's theorem, find Rn and In of the circuit figure at terminal. In this we can see there is a dependent source. There is a dependent source of 2 Ix. Okay, and we are seeing here this is 10 volt. If this in between this node it is 10 volt, then this is also 10 volt. 4 ohm across the voltage across 4 ohm will also be 10 volt. Okay, therefore I can find Ix. Ix will be 10 upon 4, that is equal to 2.5 ampere. If Ix is 2.5 ampere, then 2Ix is equal to 2Ix is equal to 2 into 2.5, that is equal to 5 ampere. Okay, if I have to calculate IN, short circuit current, now I can redraw the circuit. Plus minus 10 volt. This is 4 ohm. Okay, this is Ix, 5 ohm. This is 2Ix, and I have calculated that this is 5 ampere current source that is going through, and this is the ISC. Then I can say this is 10 volt, then ISC or Norton current, ISC or Norton current is equal to 10 upon 5 if I am applying nodal here. Okay, 10 upon 5 plus 5 ampere KCL apply. We have applied KCL here. 10 upon 5 is the current going through the 5 ohm resistance, and the 5 ampere current source this. So 10 upon 5 is 2 ampere, 2 plus 5, that is equal to 7 ampere. Norton current is coming out to be 7 ampere. Now we have to calculate the Norton resistance. For calculating the Norton resistance, we have to we have to short circuit the voltage source. Okay, by short circuiting the voltage source, and 5, by short circuiting the voltage source, this 4 ohm is across this 4 ohm, no current is flowing through 4 ohm. I is equal to 0. If Ix is 0, then this is also 0. This is also 0. Okay, then only 5 ohm resistance is equal to Rn, that is Norton resistance. Norton resistance will equal to 5 ohm. Now we have to make an equivalent circuit. Then In is connected in parallel with Norton resistance. Rn is equal to 5 ohm and IN is equal to 7 ampere. This is how we can convert a linear two-terminal circuit into a Norton equivalent circuit. I hope your concept will be cleared from these two questions based upon Norton's theorem. If you have any doubts, please ask me in the YouTube comment section or in the Telegram group. And I hope this is my first video that I have recorded in English. I hope you have understand well from this. Okay. Okay, then we will meet in the next video. All the best.